The purpose of this video is to really get a good understanding of the difference between a factor and a root of an equation and what kinds of things you can be asked and what the best way to go about them is. So to start, kind of give you a basis, I'm going to give you a really basic quadratic equation. So if you were given this, I think probably the easiest thing to do would be just be to factor it. And hopefully if you factored it, you'd quickly figure out that this would become x minus 7 and x plus 6. Once you're factored, you're doing what we call in class dropping and splitting. You're setting both of these equal to 0, and you'd end up with an answer of 7 and an answer of negative 6. So I go through that because I want it to be really clear that if a factor of something is x minus 7, its root, so this one's the root or the solution, that's another name for it, also called zeros. There's a lot of names for this in math. The root always has the opposite sign as the factor. That worked here as well. Here's my factor, here's my root of negative 6. So again, this is a root or a solution or a 0, whatever word you prefer. We typically use root the most. So again, if you have a factor, then to get it, the solution that goes with it, you change the sign, just like what happens when you drop and split. Okay, so let's look at some things you can be asked about some bigger polynomials. So this says, is x plus 3 a factor of x squared minus 5x minus 24? Okay, so what that really wants to know is if I was to divide this by this, I want to know if I get a remainder or not. That's what it really means to find out if something's a factor. If you've watched the operations with polynomials video, you hopefully already know how to divide two things like this. And the quickest way, I think, is to use what's called synthetic division. So remember, if this is the factor, with synthetic division, you always change the sign of the number. And then we're going to just list out the coefficients of the divisor. So 1, negative 5, negative 24. Leaving that space, dropping down your first coefficient, and now going through the process. 1 times negative 3 gives me negative 3. Now I add straight down. That would give me negative 8. Negative 8 times negative 3 is positive 24. And oh wow, I do. That number right there is my remainder. That's a good sign. That means yes, x plus 3 is a factor of x squared minus 5x minus 24. So that's your answer, and your justification is right there in the mathematical work that you did. I could also word it like this. Now I'm saying, is negative 2 a root of x cubed minus 4x plus 5? That really means, is x plus 2 a factor? Those questions are exactly the same, but they've already basically taken the dropped and split version. And so that means, again, if you're going to use synthetic, which I think is the fastest, you don't need to change any signs. You're going to go ahead and put negative 2 in that little box. List out your coefficients, but hang on, careful, make sure you notice that this is missing your x squared term. So I need to insert a 0 right there. If you don't, you won't really get the right answer. So 1, 0, negative 4, positive 5. Okay, so again, drop down my first coefficient, 1 times negative 2. This starts to go really fast once you get the hang of it. 0, I get a 0 here, but careful, that's not my last one. 0 times negative 2. Oops, I'm sorry, it's just 0. But 5 plus 0 is 5. So that is not true then that negative 2 is a root, meaning x plus 2 is not a factor. So the answer to this is no. And again, our justification is there. We didn't get a remainder of 0. Okay, and I could also ask you something like this. I'm telling you that x equals 2 is a root. And now I want to know, what are the other roots? Well, if you take a look at the fact that the degree of this polynomial is 3, that means I should have 3 roots. That's what that tells me. So they're giving me one of them, and there must be 2 more that I have to find. Again, I think the easiest way to go about this is use synthetic. You know this is going to work, but go ahead and put 2 in the box anyway, because then we can at least break down this function. Listing out my coefficients. You could use long division for this. For any of these, you could use long division. It's just going to take you a lot longer, hence the name. Okay, drop down your 1. You know here that you should be getting that 0 at the end because I told you that it's a root. 0, 0 times 2 is 0. That gives me 5. 5 times 2 is positive 10. Okay, good. That's good news. I was hoping it would work out. Now, in order to find the rest of the roots, I have to figure out what is this polynomial that I'm left with. That's my remainder. I don't need that 0 anymore, but this would actually be x squared plus 0x plus 5. Or if you want to just make this a little simpler, make this x squared plus 5. That's what I have to solve. So I'm going to set this equal to 0. You have options here. You can keep that 0x and try to factor it like a trinomial. You could complete the square. I think the easiest way here is to take that little square root shortcut. I'm going to subtract 5 on both sides.